idea behind parent functions is, look, if it fits into the linear form, it's going to be a straight line. If it has an x squared in it, it's going to be a parabola. Okay. If it has an absolute value, it's going to be a v. That's what the parent function is all about. And the parent function is sort of the plainest function that there is, without being multiplied by anything or added or subtracted. It's just a plain old like y equals x squared. And so why it's called a parent function is that any changes to that function by adding, subtracting, multiplying, dividing, that will have an effect on the graph of the parent function. But like we talked about yesterday, you know that when you have an absolute value, it's always going to be a v. Now the shape of the v could change. It could be fatter, it could be skinnier, it could be wider. Okay, it can shift on the grid, and that's what and what we're going to do is figure out how those numbers affect those kinds of things. Okay, now there's 3 parent functions that we're going to look at, and they're all in your book on page 301. If you'd rather screenshot from your book, I suggest that you do that rather than try to take a picture of the screen. It's cleaner that way. Plus, there's going to be more than one. I covered over 2 slides. So the first one's the constant function. We talked about this already. Whenever it's just a y equals a number, a constant, it's going to be a horizontal line. Okay. And the domain's all real numbers. The range is just whatever that value is. Okay. In that example, y equals 1. Domain's all real numbers. Range is 1. Okay. And we've looked at some of those when we went through the functions already. Okay. The next one is known as the identity function. It's called the identity function because y equals x. They equal each other. And it passes through the origin. The slope is 1. So all the points on that line have the same values. 1, 1, 2, 2, 3, 3, 4, 4, etc. And that's why it's called the identity function. It's the basis for all linear functions because, as we know, we can multiply by stuff, we can divide by numbers, we can add and subtract, and that will affect the way that line looks, but it'll still just be a straight line. Okay. There's 2 more, and like I said, if you took them from 301, you'll see that there's 4 there altogether. The next one is the absolute value function. We talked about that yesterday. It looks like a v. Domain's all real numbers. There's an upper or lower boundary based on which direction the v is facing. If it faces up like this one, the range is going to be y greater than or equal to whatever that bottom value is. And if it goes the other way, then it's going to be less than or equal to whatever the top value is on y. Okay, the last one is the quadratic function. That's the y equals x squared. It looks like a parabola. And same thing with the domain and range for the absolute value in the quadratic function. It's all real numbers for the domain. The range, if the parabola opens up, is going to be y greater than or equal to whatever the smallest y value is. If it's an upside down parabola, then less than or equal to. Okay? Those are the 4 functions that we're going to mess with. That's sort of the base function. Okay? It's like when you go to buy a car, you get the base model of the car. Then you're like, you know what? I want to change the tires. I want to upgrade the sound system. I don't like the color. I want to do something different. I'm going to go, instead of cloth seats, I'm going to go leather seats. So then once you take that base model and you start altering it and changing it, you get a different car, even though it's still a car. Okay? It still is whatever the brand of car is that you want to buy, right? Same thing is true with these parent functions. If there's an absolute value, it's still going to look like a v. It might not look like the same v, but it's still a v. Parabola is still going to be a parabola. It just might be smashed down or something, or shifted over, or whatever. That's why it's called a parent function. Okay? Let's talk about all the transformations. So the changes, that's what a transformation is. It's a change. So we're going to take that parent function and we're going to change it somehow. We might change its position. We might change its direction. We might change its size. Okay? And I want to show you how doing certain things changes it in certain ways, because there's consistency to it. If you multiply the variable by an integer, it will affect it in one way. If you add a number to it, it will affect it in a different way. And that's really what the rest of this lesson is about. Okay, so translations. And we're not talking about language. We're talking about a slide. Okay, another way to call to describe a translation is to call it a slide, because you just basically change the position. You're not flipping it. You're not changing the size. You're relocating. It's sort of like if I move your seat in class. I've not changed you at all. I've repositioned you. Okay? Everything about you is still the same as it was a millisecond ago. I just happen to put you in a different place in the room. That's the same thing with a translation. Just sliding the graph around until it's in a different position.
If it slides, it can only slide up, down, left, or right? Or can it, like...
It can slide left and right, or up or down, or both.
Alright.
Okay? And all of the transformations I'm going to show you today can be combined. You can do, when we get to the end and we have all of them, I'll explain how that can all happen. Okay? Okay? Again, this is also known as a slide. You don't necessarily need to write that down. I kind of emphasize that. Okay? Slides left or right or up or down. It's really the same thing. Just over explaining why it could also be called a slide. All right, talk about it. Here's how the vertical slide happens. Okay, when a constant, remember a constant is just a plain number, no variable. When it's added or subtracted outside of an x term, and I put outside in quotation marks because, well, you're going to see in a second. You'll see what I mean by outside. Okay. Because I'm going to show you some examples, and these are examples of outside. And it has to really do with absolute value, it has to do with parentheses, it has to do with order of operations, which makes it sort of outside. Let's take a look here. Here's some examples, okay? So notice here that the plus 7 is not included in the squaring. The squaring happens first, and then there's a plus 7. The absolute value happens by itself, and then there's the minus 3. Okay, the x, there's nothing happening. It's not in parentheses. It's not forcing it to be added with the x first. The way I kind of describe this is that they are all happening outside of the variable. They're separate. Okay? And when they're separate, all you have to do is look at the number and go, okay, it's outside, so it's an up or down. Well, what do you think for this first one? Plus 7. Do you think it's going to make it move up, or is it going to make it move down? Okay, why up? Why do you say up? Positive. Okay, we associate vertical moves, we associate positives with upwards. This is what's happening. So in your homework, it's going to ask you, how does this transformation affect the parent function or something like that? All you have to say is it moves up 7. All right? What's the second one going to be? Down 3. What's the last one going to be? Up 9. Okay. Simple enough. When it's outside, it's just like that. When it's outside the variables, it just shifts up or down. Okay? Any questions on that? That's just a vertical shift. That's a vertical slide. Okay? Horizontal works a little bit different. Okay? And I pointed out to you in red. Okay? The horizontal slide happens when you add or subtract inside of an x term. And when you see the examples, you'll see what I mean when I'm distinguishing between inside and outside. Okay, it'll make a little more sense. It'll be inside the absolute value, it'll be inside the squaring, it'll be inside parentheses, and it actually shifts or slides in the opposite direction of the sign. So with the y, it's the same. Plus means up. Minus means down. When it's inside with the x, it will shift in the opposite direction that you think it would shift. Okay? Plus no longer means to the right inside a set of parentheses. It means to the left. Minus inside a set of parentheses, or inside an absolute value, or inside a squaring function. Minus, instead of meaning to the left, actually means to the right. Okay? That's why I put the word opposite up here. That's why I put it in a different color to really emphasize it. Okay? So again, here's a couple examples. So now you see what I'm saying about inside? See how the adding or subtracting is happening inside parentheses, inside the absolute value? So because of that, this is going to be a horizontal shift. Now, this is minus 5, but because it goes in the opposite direction, which way is this going to shift? Right 5. Opposite of what you think. That goes right 5. What about the bottom one? Left 2. Okay? That's all there is to it. So what would have been helpful yesterday when you were graphing your absolute value and you're trying to figure out where it turns, if you'd have known this then, you'd have been like, okay, I just got to take the regular absolute value and it's going to shift over, slide it over, and then I have a better idea where it starts. And I kind of wish the book went in that order, but it doesn't. Maybe I'll change it next year. Okay? Questions on that? All right. Those are the slides. Another reflection is a flip.
I have a question.
And it literally just means flip it over. Now, when a reflection, when a parent function flips, it's going to do that over the x-axis or over the y-axis. So when you've worked in your Word documents or whatever word processing or graphing applications that you've used, or when you take a JPEG or something and you're changing it to fit it in your document or presentation, when you flip it around, okay, so you got the horizontal flip and you have a vertical flip. You guys know what I'm talking about? That's what this is, okay? So when it flips over the x-axis, right, it's one of those flips. When it flips over the y-axis, it's another one of those flips, okay? And the way that it does it is with the sign. Okay, the negative sign will make it flip. So if the negative is outside of the x, so again, same idea with parentheses or absolute value or squaring. If the negative is outside, then it flips over the x because the y value signs change. So here are 2 examples. You're saying, well, this looks like 3 examples. The reason I wrote this over here is because when you see this, do not think that this minus is being squared. Remember order of operations. We do powers before we do multiplication. So what you have to think when you see this is that there's like this huge space. The squaring's happening. The minus is not affected by the squaring. Obviously, this one is clearly outside. There's an x inside. So this would take the absolute value parent function and flip it over the x-axis. It would turn it upside down. This would take a parabola and flip it upside down. Okay? Right over the x-axis. Okay? If the negative is inside of the x, so like here, if it was inside the absolute value or inside and squaring it, then it flips over the y-axis. This. Okay? Again, that inside-outside idea. If it's inside, it flips over the y. If it's outside, it flips over the x. All right, last one is called a dilation. And when we talk about dilations, I think it's easier to talk about those JPEGs again. When you make them bigger and stretch them out, okay, you change the size of your picture. That's what a dilation is. It can be an enlargement. It can be a shrinking of something. We like to call it stretching it or compressing it, because what happens is you take that parent function. So, when you change the size of the picture and they have the horizontal percent and the vertical percent, and you set it to change one of the the horizontal percentage, but you don't change the vertical percentage, and it stretches it or smashes it down, that's what's happening here. That's what happens with these dilations. Okay? When x is multiplied by a number greater than 1, okay, a number greater than 1, then it's stretched. So it's like you pull it, sort of like, think of a water balloon, right? When you fill that water balloon with water at the faucet, it just starts stretching and pulling down. That's what happens when you have a bigger than x number, or bigger than 1 number, multiplied by x. And I have an example. Okay, so here's my parent function. Okay, that's y equals x squared. Okay, that you don't have to copy that down. Okay, but if I multiply it by a number, for example, like 5, this is x squared times 5. Notice it's like grabbing the parabola and pulling it upwards, and it makes it look skinnier. Okay, that's a stretch because I multiplied this number by 5. Now I'm going to put a graph where they're both on the same. So if you want to take a picture of this, where you see how, for example, multiplying it by a number bigger than 1 pulls that parabola up. The red is the parent function. The blue is the stretch, or the dilation. Okay, now, the other thing that we can do is we can take and smash or compress the parent function. Okay, which will make it fatter, wider. That's what a compression is. And in order to do that, we have to multiply by a fraction. Okay? So a fraction greater than 0 but less than 1. So when I multiply by a fraction that's between 0 and 1, it will get compressed. It'll get smushed down. And again, here's some examples. Okay? On the right, I multiplied by 1/4. So the left is the parent function, and then I multiplied it by a number between 0 and 1, and it smushes it down, which makes it fatter. And again, if you want to see them together, that's what it would look like. Okay? So that's just smashing the parent function down, pushing it down from the top when you multiply it by a fraction.